Guys, today we're going to finish these notes on solving and graphing inequalities. Yesterday we worked up through example 11, and we're going to look at starting with example 12 today. Identifying solutions. It says circle all possible solutions to the inequality. So what you want to do first before you can circle which choices work for that inequality is you want to solve first. So I'm going to solve the inequality. First I notice that x is on the right side, so I'm going to rewrite this as 3x minus 1 is less than negative 25. And then I will solve. I'm going to add 1. 3x is less than negative 24. Divide by 3. X is less than negative 8. Be careful, negative 8 is not a solution. It's all numbers less than negative 8. So negative 5 is not less than negative 8. Negative 12 is less than negative 8. And negative 35 is less than negative 8. All right, so just be careful it doesn't say equal to. And now we're going to move on to something new, and that is something called interval notation. Interval notation is a way of expressing a solution set other than a graph and the inequality itself. So, for example, in example 13, if you wanted to show x is greater than negative 5, we know that on a graph that means that we're looking at all numbers that are bigger than negative 5. So I'm just going to show these three numbers. Bigger than, but not equal to. So anything to the right of negative 5, but not equal to negative 5. So to express this in interval notation, what we do is we say x can be any number from negative 5 all the way till the biggest number ever, which is infinity, which is not really a number, but it's the concept of continuing to get larger and larger. So I'm basically looking at my number line when I do this, and I'm reading it from left to right. Any number from negative 5 all the way to infinity. Now, I don't want to include negative 5, so what I do is I use parentheses around my interval notation to say I'm not including these. Negative 5 is not included because it doesn't have an equal sign, and infinity is not included because infinity is not an actual number, so you can't ever actually include it. Okay, go to the right to example 14. And we're going to take a look at similar inequality, only this time there's an equal sign. X could be any number greater than or equal to negative 5. So again, here's my number line. I want to include negative 5 as a solution, so I color in my circle. And I'm including anything bigger to the right again. So my interval notation is going to say, once again, x could be any number from negative 5 all the way to infinity, but this time I want to include negative 5. And what I do is I put a hard bracket, a squared off bracket, to say negative 5 is being included. Infinity cannot be included. It's not a real number, so we use parentheses. Okay, so just to add some notes here. Here, we're not including the negative 5, and here we are including. Okay, because of the hard bracket. So now we're going to go look at graphs that go less than, that go to the left. The first one says x is less than negative 5. So a graph looks like this. Here's negative 5, negative 6, and negative 4. Any number less than negative 5, but not including negative 5. So our interval notation is going to go from left to right. It's going to say x could be any number from the leftmost part. So I'm going to highlight from here all the way to negative 5, but not including it. So we say from negative infinity, because the smallest possible number is negative infinity. Any number from negative infinity all the way to negative 5, but not including the negative 5. Okay, again, we read from left to right, and so what I did was, I'm highlighting again, is I went from negative infinity all the way up to negative 5, but not including the negative 5. And then a similar graph would be on number 16, x is less than or equal to negative 5. So any number less than or equal, I'm including the negative 5, and I'm going to the left. Again, we read the graph from left to right. We say x could be any number from this left arrow, negative infinity, all the way up to negative 5, including negative 5. So my interval notation will say any number from negative infinity all the way up to negative 5, hard bracket, including the negative 5. Okay? And it must be in this order. You must go from left to right on these, right? From smallest to biggest to largest. So we'll look at one more where we're kind of putting it all together. Example 17 here, where we're going to solve, graph, and then express in interval notation. So I'm going to solve. I'm going to isolate x, add 12. Negative 3x is less than 33. Divide both sides by negative 3. I'm dividing by a negative. I have to flip, switch the inequality. X is greater than negative 11. So on a graph, here's negative 11, negative 12, and negative 10. X is any number bigger to the right of negative 11, but not including it. Take a minute and pause the video and see if you can write the interval notation. So the interval notation should be any number from negative 11 all the way to a positive infinity, not including either number. And we're going to look at one last one. This one contains fractions. Now, inequalities that contain fractions are just like equations that contain fractions. You want to make sure that you are first clearing the fractions. Okay. So my LCM is between 3 and 4 is 12. So I'm going to multiply all terms by 12. Times 12, times 12, times 12, times 12. And remember, we're dividing. The 12, this isn't going to go away, clearing fractions. It's going to be, again, all year, next year, the year after. This keeps going. So divide 12 divided by 3 equals 4. And we multiply 4 times 2x is 8x. Multiply 12 times negative 1 is negative 12. Bring down the inequality. Divide. 12 divided by 4 equals 3. 3 times 3x is 9x. And then multiply 2 times 12 is 24. Once your fractions are gone, now try to isolate x. I'm going to subtract 9x because I want my x's on the left side. So I'm trying to bring my x's over to the left. I have negative x minus 12 is greater than or equal to 24. I'm going to add 12 to both sides. I now have negative x is greater than or equal to 36. You can't leave the negative there. That's really a negative 1. I'm going to divide by negative 1. And remember to switch the inequality. X is less than or equal to negative 36. So on a graph, here's negative 36, negative 37, and negative 35. X is less than or equal to negative 36, so I'm going to color in my circle to say it could be equal or less to the left. Take a minute, pause the video, see if you can write the interval notation. It should be from left to right, negative infinity all the way up to negative 36, including the negative 36. All right, so these should help you with tonight's homework. You have 2 parts to your homework, 2 sheets to work on, and I will see you guys tomorrow. Thanks.